Hello everyone, welcome back to my channel Master Computer Science subject. Today in this video we are going to see the definition of LL1 grammar, and also we are going to check whether the grammar is LL1 or not without constructing the LL1 parsing table. This definition will help for that. So first we see what is LL1 grammar. A context-free grammar G is said to be LL1 if and only if there is a production rule A derives alpha as well as beta. There are two alternatives on the right hand side, at least two alternatives on the right hand side. And if the following conditions are there, what is the first condition? For no terminal A, do both alpha and beta derive strings that begin with A. It means if you try to find first of alpha, by the way, first of A and first of beta, both should not contain the same symbol. That is the meaning of the first rule. What is the second rule? At the most, either alpha or beta can derive the empty string. It means not both alpha and beta cannot derive the epsilon. So from the first and the second rule, I can say like this. First of A, we can find by finding first of alpha as well as first of beta. Right? So the condition says that first of alpha and first of beta are disjoint sets. In the sense, the intersection, if you find between the sets of first of alpha and first of beta, it is null. So this we have obtained from the rule number 1 and 2. Right, now let us see what is the rule number 3. The rule number 3 says if beta derives epsilon, then alpha must not derive any string beginning with a terminal which is in follow of A. Similarly, vice versa. Vice versa means if alpha derives epsilon, then beta does not derive any string beginning with a terminal that is in follow of A. So what the third rule says, this is actually the combination of rule 1 and 2. Now what the rule number 3 says? Rule number 3 says first of alpha intersection follow of A is null when if beta derives epsilon. Similarly, first of beta intersection follow of A is also null when alpha derives epsilon. So if you remember these two rules, so from any grammar we are able to identify whether it is LL1 or not without constructing the parsing table. So let us see some examples for that. So I have some examples here. So check whether the following grammar is LL1 or not without building the parsing table. So this is a given grammar. In the given grammar, we are going to first compute the first and follow. So what is first of S? First of S is A from this production rule and first of S is B. So let me write it. And first of S is epsilon also. So what is the rule number 1 and 2 says? When you try to find first of alpha and first of beta, the symbols should not be the same. It should not derive the string which begins with the same symbol. So the first rule, actually we have derived one condition which is a combination of first and second rule. So I'm talking about the condition now. So the first condition is true in this case, right? Okay, now let us move on to the second one. I'm going to find the follow set of S now. Follow set of S, by default it includes dollar. What is follow of S as per the first rule? It is B. Let me include that. There is one more S here. If I try to find the follow of S for this, it is nothing but once again the follow of S itself. Okay, now from this rule, if I try to find what is follow of S, it is A. From here, if I try to find follow of S, it is nothing but the follow of S itself. So follow of S is $AB. These are the three symbols. Okay, now let us recollect the second condition. What is the second condition? If first of either alpha or beta derives epsilon, then the follow set of yes should not contain the same symbols whatever is there in first set. So let us take this is first of beta. First of beta is what? Epsilon. First of alpha is A and B. Now see what is follow of S. Follow of S also contains A and B. So the second condition says that for if you have the rule A derives alpha or epsilon, if A derives epsilon, then first of alpha intersection follow of A should be null. But this condition fails. So the given grammar is not LL1 grammar. Now let us move on to the second example. As for the second example, let us compute first of all the first and the follow set. First of S is E. First of C is C as well as epsilon. First of D is D as well as epsilon. Yeah. First rule, S derives, only one rule is there on the right hand side, so there is no need to check the condition 1 for here. Now let us check the condition 1 for the second and the third rule. For the second and the third rule, when you check the first symbol, the both are different. So the first condition is true for this grammar. Now let us check the second condition. To check the second condition, you have to compute the follow set. What is follow of S? Follow of S is by default $. What is follow of C? Follow of C is first of D. What is first of D? It is D as well as epsilon. But you can have only D in the follow set, isn't it? In place of epsilon, what you are supposed to do? Replace this D by epsilon. So follow of C is F. So we found follow of C. Now let us find what is follow of D. Follow of D is F. Okay. So we have found the follow set of C as well as D. Now what is the second condition? If you have a rule of the format A derives alpha or epsilon, first of alpha and intersection follow of A should be null. Right? Of course. First of C contains epsilon also. First of C is also C. Find the intersection between these two things. First of alpha and follow of A. If you find intersection, it is null. So second condition is true for this rule. Similarly, we check the second condition for the third rule also. What the third rule says? First of D is epsilon. This is alpha, this is beta. One of the rule gives you the epsilon. So for the other rule, find the first set. What is the first set? It is D. And check with the follow set. Follow set is containing F. These two symbols are disjoint. Actually, these two symbols are in two disjoint sets. So this grammar is LL1 grammar. This is LL1 grammar. Now let us quickly move on to the third example. What is first of S? First of S is first of A. If A is replaced by epsilon, first of S is first of B, which is B. First of S is epsilon also, because A can be replaced by epsilon, B also can be replaced by epsilon. So first of S is A, B, epsilon. What is first of A? It is A as well as epsilon. First of B is B as well as epsilon. Now let us identify the follow set of S. Follow set of S is only $, because we don't have any rule which contains S on the right hand side. What is follow of A? Follow of A is first of B. So which is B. But if this B is replaced by epsilon, follow of A is follow of S. So by the way, we have to include $. What is follow of B? Follow of B is follow of S, which is follow of B, which is $, because after B there is no symbol. So to find follow of B, we have to consider follow set of S, which is $. Now we are going to check whether it is LL1 or not. Okay, for the first rule, yes, there is only one alternative, so no need to check the condition 1. But for the second condition, there are two alternatives. You have the rule of the form A derives alpha or beta. So alpha derives A, beta derives, the first of beta is epsilon. So two different symbols, so no problem. Similarly for this rule also, when you try to find the first set of alpha and beta, both are deriving a different symbol. So the condition 1 is true in this case. From the condition 1 we can say it is LL1, but we have to check at the condition 2. So what is condition 2? Wherever there is epsilon, there and all, we have to check the follow set. Find first of S. There is only one option here, which is epsilon. Okay, when you compare the follow set, both are disjoint sets. In fact, you can skip this because we have only one alternative on the right hand side. Now move on to the second rule. First of alpha is A here, but first of beta is epsilon, isn't it? So you have to check whether the first of alpha and follow of A are disjoint sets, whether there are no symbols in common. Yeah, there are no symbols in common for this. So second condition is also true. Now let us move on to the third one. In the third one, first of alpha is B, whereas first of beta is epsilon. So check whether the first of alpha intersection follow of A is equal to null. Yes, the condition is true. If that is the case, this is not this is LL1 grammar. So both the conditions are true. This is LL1 grammar. Now let us see the last example. This is a grammar. Already for this grammar I have computed the first and follow set. Okay, now we are going to check only the conditions. Okay, let us check the first condition. What is the first condition? When you find the first of alpha and first of beta, both should be disjoint sets. Yeah, first of S, from this rule it is I, from this rule it is A. Both are disjoint. So condition 1 is true. Now let us check for the second rule. For the second rule also, first of ES is E, first of epsilon is epsilon. These two are two different symbols, by the way, disjoint sets. First of E is B. Yeah. So condition 1 is true for all these rules in the given grammar. Now let us go for the second condition. What is the second condition? If the first set is containing epsilon, so we don't need to check for the variable S. Now we go for the variable S dash. For S dash, there are two symbols, right? When you find the first set, one is epsilon. So first of alpha is E, whereas first of beta is epsilon. If first of beta is epsilon, what do you need to find? First of alpha intersection follow of A should be null. But when you find first of alpha intersection follow of A, if I apply as per this, first of ES, it means first of S dash intersection follow of S dash. So what is first of ES? It is E, intersection follow of S dash is $E. There is a common symbol. If you find intersection, there is a common symbol. So second condition is false. Right? So when the second condition goes false, the given grammar is not LL1 grammar. So this is how we have to find the grammar, whether it is LL1 or not, without building the parsing table. Okay, now let us have a closer look how the rules are telling. See, for example, you take this. First of S dash is E, isn't it? Then against the column E, S dash comma E, in the parsing table, we will be writing the rule S dash comma ES. But whenever the first set of S dash contains epsilon, obviously we move on to the follow set. So in the follow set also, S dash comma dollar, S dash comma E again, we will be entering the rule S dash derives epsilon. So S dash comma E in the parsing table, in the corresponding cell, we will be writing two rules. One is S dash derives ES, another one is S dash derives epsilon. That is why directly we are just checking the intersection among these two sets, and if there is some common symbol, we are straight away claiming that it is not an LL1 grammar. You can build the parsing table for this grammar and you can cross verify. I hope you have understood this trick. Please practice these problems, and if any doubt is there, please comment in the comment section, and also subscribe to my channel. Thank you.